Atomic structure and periodic table revision for Edexcel IGCSE Chemistry. All matter are made up of atom. An atom is formed of a nucleus and electrons which orbit the nucleus and shells. Looking more closely at the subatomic particles, we can find that the nucleus is found in the middle of the atom, and the radius of the nucleus is very small compared to the radius of the atom. The nucleus contains two types of subatomic particles. It contains protons and neutrons. You can look at the relative mass of both protons and neutrons. Both of them have a relative mass of 1. However, the protons have a relative charge of +1. The neutrons are neutral and they have a relative charge of 0. This is why the nucleus is positively charged. Almost the whole mass of the atom is concentrated in the nucleus. And then we have the electrons. The electrons will move around the nucleus in shells. They are negatively charged because the electrons are negatively charged. They are very small in size. This is why we say that the most of the mass of the atom is concentrated in the nucleus because the mass of the electron is neglected. The volume of the orbits of the electrons will determine the size of the atom because the electrons, even though they are very tiny, they cover a lot of space. The number of protons inside the nucleus will equal the number of electrons which orbit the nucleus. This is why atoms are neutral. However, this is different from ions because ions are formed when atoms start to gain or lose electrons. So the number of protons will be different from the number of electrons. If an atom gains an electron, the number of electrons will be higher than the number of protons and the ion will be negatively charged. If the atom loses an electron, then the number of electrons will be less than the number of protons and then the ion will be positively charged. We have two different numbers for any element. We have the atomic number, which is the number of protons in the atom. So let's look at the atom of sodium. This is the atomic number of sodium, which is 11, meaning that sodium has 11 protons. It also means that for an element of sodium or for an atom of sodium, not an ion, it will also have 11 electrons. And then there is the mass number. The mass number is the total number of protons and neutrons. So the mass number of sodium is 23, meaning the number of protons and neutrons inside the nucleus are 23. The number of neutrons here can be calculated where the number of neutrons equals mass number minus the atomic number. The nuclear symbol of any atom will give you both the atomic number, which is written at the bottom left, and the mass number, which is written at the top left. Isotopes are different forms of the same elements which have the same number of protons, but they have different number of neutrons. So isotopes have the same atomic number, but they have different mass number. Example of that is carbon-12 and carbon-13. Both of these have an atomic number of 6, so the number of protons and electrons in both of these are 6. But the mass number here is different. Carbon-12 has a mass number of 12, meaning the number of neutrons is 6. However, carbon-13 has a mass number of 13, meaning the number of neutrons is 7. We can calculate the relative atomic mass. Relative atomic mass is the average mass of a certain atom, taking into account the different masses and the abundances of all isotopes that make up the element. Many elements can exist as a number of different isotopes. Relative atomic mass is used, and it's the one that is reported in the periodic table instead of the atomic mass when we refer to a certain atom. We can calculate the relative atomic mass if we add the total of the percentage of every isotope times the mass of that isotope divided by 100. For example, Chlorine has two isotopes, chlorine 35 and chlorine 37. The relative abundance of these two isotopes is 3 to 1, or if we want to write them as percentages, it's going to be 75% and 25%. So we can calculate the relative atomic mass for chlorine by multiplying 35, which is the mass of the first isotope, times the relative abundance of that isotope, which is 3 in this case, plus 37, which is the relative mass of the second one, times 1, which is the relative abundance, all divided by 4, which is the total of the relative abundance of all of these isotopes. And then the relative atomic mass for chlorine is 35.5. Electronic structure. The electron shell rule. So electrons always occupy shell. They orbit the nucleus in a certain energy level. These shells have different energies. The lowest energy level has to be filled first with electron, which is the one which is closer to the nucleus, which will have the lower energy. It has to be filled first, and then we need to add the electrons to the following electron shells. Only certain number of electrons are allowed in each energy level. The first shell has a maximum of 2 electrons, second shell has a maximum of 8 electrons, and third shell has a maximum of 8 electrons. A shell must be completely full before electrons start to fill the next one. The shell which is at the outside is called the outer shell, while all the other shells which are full are called the inner shells. We can work out the electronic structure of any atom if we know the atomic number of that particular atom. For example, what is the electronic structure of carbon? The electronic structure of carbon can be determined when we look at the atomic number of carbon, which is 6. So it has 6 proton, which means it also has 6 electrons. Then the electronic configuration of carbon would be 2 and 4, because the distribution of the electron in different electron shells is called the electronic configuration or the electronic structure. Another example is the electronic structure or the electronic configuration of magnesium. Magnesium has an atomic number of 12, which means it also has 12 electrons. So the electronic configuration of magnesium would be 282. You can show the electronic structure as a diagram or as numbers as we have seen. Example of that is potassium. Potassium has an atomic number of 19, which means it has 19 electrons. So the electronic configuration of potassium would be 2881. We also can show the electronic structure using the diagram as follow. So you can see that the first energy level has 2 electrons, the second one here has 8 electrons, the third one has 8 electrons, and the outer shell has 1 electron. The periodic table. The first periodic table was described by Dmitry Mendeleev. Dmitry Mendeleev took 50 elements that were discovered at that time, and he arranged the elements in order of atomic mass. He didn't arrange them in order of atomic number because the atomic number was not discovered at that time, or protons were not discovered at that time. Only the mass of the atom was known at that time. He kept the element of similar properties in the same column or in the same group, and he started to move some of the elements from their position so they can fit into the properties of the group. So that when they fit well into a certain group, he would move them from one group to another. And he left some gaps as well. Later on, when other elements were discovered, they fitted well in the gaps. And then we have the modern periodic table. The modern periodic table, the elements are arranged in order of atomic number, not in order of atomic mass. We have the periods, which are the rows, and then we have the groups, which are the columns. atoms. The elements in the same group will have the same number of outer electrons, outer shell electrons, and they will have similar chemical properties. So we have group 1, they have 1 electron in their outer shell. Group 2 will have 2 electrons in their outer shell. Then we have group 3, which will have 3 electrons, group 4, 5, 6, 7, and then the group at the far right of the periodic table is called group 0 elements, which is the noble gases. These elements have full outer shell of electrons. The elements within the same period will have the same number of electron shells, but the properties will change along the period. We can use the periodic table to predict or to find the electronic configuration of the first 20 elements in the periodic table. So we have the period number. The period number will give us the number of electron shells. So elements in period 1 will only have 1 electron shells. The elements in period 2 will have 2 electron shells. In period 3, 3 electron shells, and period 4, 4 electron shells. And then we have the group number, and the group number will give us the number of electrons in the outer shell. So we know that group 1 will have 1 electron, group 2 2 electrons, and so on. Don't forget that the final group is called group 0 elements, which have full outer shell of electrons. So let's have an example. So looking at nitrogen here, so nitrogen is in period 2, which means it has 2 electron shells, and it's in group 5, which means it has 5 electrons in the outer shell. So the electronic configuration of nitrogen is 2, 5. Another example is silicon here. So silicon is in group 3, so there are 3 electron shells, and it's in group 4, which means there are 4 electrons in the outer shell. So the electronic configuration of silicon is 2, 8, 4. Finally, there is calcium as well here. This is in period 4, which means there are 4 electron shells, and it's in group 2, which means there are 2 electrons in the outer shell. So the electronic configuration will be 2, 8, 8, 2. Group 0 elements, as we said, the elements in the group at the far right of the periodic table are called group 0 elements. Group 0 elements, or noble gases, they are inert colorless gases. All group 0 elements have full outer shell of electrons. They are inert and they are non-reactive, and they don't need to give up electrons or gain electrons to become more stable. Full outer shell confers stability. This is why elements will give up electrons or will gain electrons in order to reach the full outer shell configuration, which give them more stability. Group 0 elements exist as monoatomic gases. They exist as a single atom, not bonded to each other. You can compare between noble gases, something like neon or helium, which exist as monoatomic, compared to gases like oxygen or nitrogen or even chlorine or fluorine. All of these are diatomic. They are not noble gases. They tend to gain electrons or share electrons, but this is why they exist as diatomic molecules, not as the monoatomic like the noble gases. When you look at the properties of group 0 elements, the boiling point of noble gases increases as you move down the group. This is because the increase in the relative atomic mass. So as we go down from helium to neon to argon to krypton, there is an increase in the atomic mass and in the size of the atom. So there is an increase in the boiling points of the noble gas. We can also look up metals and non-metals from the periodic tables. Most elements in the periodic tables are metals. Metals are the elements which can form positive ions. They tend to lose electrons to give positive ions, and we can find the metals mostly in the left, towards the left and the bottom of the periodic table. Non-metals are at the far right and top of the periodic table. These are the non-metals, and non-metals do not lose electrons. They tend to either gain electrons to give negative ions, or they share electrons, as you will know later on when you learn about the different types